This is the first day of section 7.5. We're going to talk about the properties of trapezoids. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. All right, the parallel sides are called the bases. So here we actually have a picture, a diagram of a trapezoid with its bases. Right? These sides are parallel, they're the bases. The base angles then are the consecutive angles whose common side is a base. Right? They're called base angles because they share a base. So on base BC, angles B and C are base angles. And on base AD, angles A and D are base angles. The non-parallel sides, or the non-bases in a trapezoid, are called the legs of the trapezoid. Now, trapezoids in general don't have to have any sides congruent, but there is such a thing as an isosceles trapezoid. So if the legs of the trapezoid are congruent, then the trapezoid is an isosceles trapezoid. So for all trapezoids, non-isosceles and isosceles trapezoids, you will have one pair of opposite sides being parallel, and the consecutive angles between parallel lines are supplementary. Two angles here, two angles here. If the trapezoid is isosceles, it actually gets a few more properties. So the non-parallel sides, or the legs, are congruent. The diagonals are also congruent, but notice they do not cut each other in half. That's what differs from the rhombus and the square. Or sorry, the rectangle and the square, which had congruent diagonals as well. The base angles are congruent. So if this is a base, these two angles would be the same. And for that base, these two angles would be the same. And the opposite angles are supplementary. All right, so the ones across from each other. We really don't look at that as much because we know that the ones on the same leg are supplementary, so we would probably just find the other base angle and do that. That is true for isosceles trapezoids. So let's look at our first example. I'm going to look at this and I see that I do not have congruent legs. So these angles down here are not the same and these angles up here are not the same. So I have to rely on consecutive angles. If I do 180 minus 87, I get 93. So the measure angle M is 93 degrees. And then along this leg, these angles are supplementary. So if I did 180 minus 51, I get 129. So you go ahead and try this one, pause. When you're ready to see the answer, hit play. All right, so angle A and D had to add to 180, angle B and C had to add to 180. So the measured angle C is 149 degrees, the measured angle D is 118 degrees. Now we have DEFD as an isosceles trapezoid. And notice here they have DE with a bar and the congruent sign. So we're not looking for measures. We just want to know what is DG the same as. So DG is this leg. So that is the same as the other leg, segment DF. And then DF is one of the diagonals. And remember, the diagonals are congruent. So the other diagonal, EG, is also congruent to DF. All right. You try this one. This is talking about the angles now. So determine which angles are congruent to each of these in this isosceles trapezoid. Pause. When you're ready to see the answer, hit play. All right, so angle T and angle U are congruent, and angle W and angle V are congruent. Still in this isosceles trapezoid, and I know it's isosceles because it has the congruent legs here. I want to find the measure of all the angles. So we know that the base angles are congruent. So I can say that angle Q is also 112 degrees. And then along the leg, they're supplementary. So if I do 180 minus 112, we get 68. So each of these angles then be 68 degrees. So try the next problem with this isosceles trapezoid. Pause. When you're ready to see the answer, hit play. All right, so we know the base angles of W and X are the same, so W is 47, and then the other angles have to be 47, so that's 133 for both of those. In our next problem, it's just a trapezoid. It's not isosceles because they don't tell me that PS and QR are congruent. So I'm relying on the fact that this leg has these two angles touching it, and those two angles should be supplementary. So I'm going to add them, 12x plus 3 plus 7x minus 13, and set that equal to 180. So remember, if it's on the same side, we combine. That's 19x minus 10 equals 180. Add the 10. We get 19x is 190. And when I divide by 19, I get x is 10. I actually want to find the measuring angle R. So we're going to substitute it back into the 7x minus 13. So that's 70 minus 13, or 57. So the measure of angle R is 57 degrees. So go ahead, try the next one. Pause. When you're ready to see the answer, hit play. All right, so on this problem, our angles are supplementary, so we add them to 180. We get x is 50. All right, in MNOP, we have an isosceles trapezoid, so I'm going to mark my legs as congruent. MP is 16x minus 13. NO is 9x plus 8. PN, so one of the diagonals, is 5y plus 9. And MO, the other diagonal, is 12y minus 36. Those are going to be equal because the diagonals are congruent in an isosceles trapezoid, and my legs are going to be equal. So I'm going to set my two values with x equal. Subtract 9x, add 13. We get x is 3. And then for my two diagonal lengths, we'll set those equal as well. So that's going to be 5y plus 19 equals 12y minus 37. So subtract the 5y, add the 37. And if we divide by 7, we get y is 8. All right, so go ahead, try this next problem. Pause when you're ready to see the answer, hit play. All right, so we set our two legs equal, we get x is 12, and we set our two diagonals equal, and we get y equals 5. So here we have JKLM is an isosceles trapezoid. We want to find all the missing angles. So first, these two angles are along a common leg. So they're not base angles, they're not equal, but they are supplementary. So we'll start by solving. 10x minus 33 plus 4x plus 17 equals 180. So combining, that's 14x minus 16 equals 180. Add 16 to both sides. So 14x equals 196. And dividing by 14, we get x is 14. So if I know x is 14, I could substitute it back in. So I'm going to do 4 times 14 plus 17. So 4 times 14 is 56, plus 17 is 73. So this angle is 73, and this angle is 73. So angle M and angle L. And then I have two choices. I could either take 73 away from 180 or plug 14 in for that. So let's say I plugged 14 in for that. So 10 times 14 minus 33, 140 minus 33 is 107. And those do in fact add to 180. So these two angles are each 107 degrees. So you're going to go ahead and try this one. Notice our angles now are not along a leg, they're on the base. So solve for all your angles, pause. When you're ready to see the answer, hit play. All right, so this time we set the base angles equal. So we solve and get x is 13. If I plug that to angle D, the 2x plus 27, that's 2 times 13 plus 27. We get a total angle measure of 53 degrees for both angle D and angle C. And then since they're supplementary to A and B, we did 180 minus 53 to get 127. All right, so in this problem, I want to find the measures of angles O and P, even though I'm given the measures of angles M and N. Because it's an isosceles trapezoid, I do know that those angles are congruent. So 8x minus 16 equals 6x plus 20. Subtract 6x and add 16. We get x is 18. So if I plug that in here, 6 times 18 plus 20. 6 times 18 is 108. Plus 20 is 128. And we know angles O and P have to be supplementary to 128. So if I subtract them, I get 52. So the measure of angle O equals 52 degrees, and the measure of angle P equals 52 degrees. So this is the last problem. Try it, pause when you're ready to see the answer, hit play. All right, so this time we were given consecutive angles, not base angles, so we add them to 180, solve to get x is 9. I plugged back into angle y. I did 8 times 9 minus 2. I got 70 degrees for angle y. Because base angles are congruent, 70 degrees. Now my consecutive angles are supplementary. So 180 minus 70 gave me 110 for angle W. And that is everything about trapezoids.